client, and I use the Elasticsearch API for it, the official library. I already have a library that that is in my Elasticsearch on my laptop, and it's running on the background. So here I use indices API. I use client.indices.getAlias, and I get all of the indices. And what I call indices here is the collections of documents, and they are named after the category of the Wikipedia articles that I scraped them from.
Olesya, there is a small, someone from the crowd asked if you can zoom in a little bit.
Okay, I'll try. Thank you. Is that better?
Yes, thanks a lot.
Okay, thank you for telling me. Yeah, so these are the categories I have. I have like maybe 300 articles in all these different categories. So when you import the documents into Elasticsearch, it actually has a predefined set of data structure. You actually don't need to define the data structure. You just give it the JSON file or a dictionary. And in this case, it recognizes that the page ID that I'm taking for the Wikipedia article, it declares it as a long, and text, the body of the Wikipedia article is a text, and the title is also a text. So that's just by default. And then basically when I try to run, I'm trying to ask a question. I'm asking a question: when was Barack Obama inaugurated? Because I have this article about Barack Obama and it should find it. The simplest search version would be like this. I give it a query, I declare a query body that looks like that. So it's going to be looking in the text field. And basically here, I just wanted to show you that when you run the search, it returns a number of results. And besides the article, the documents that you entered, it will also return some metadata with it. And this, for example, is the one that we really care about right now, is the relevance score. So for the simple search, I end up with the results like this. And well, as you can see, the results number 0 with the highest relevance score is not really Barack Obama, it's actually Bill Clinton. This is why I'm doing all these experiments, so that I can improve on that, and our bot does not get some irrelevant article. We want it to be as efficient as possible so that it gets the most relevant articles for it to produce the answers from. So there are other ways to query things, like, for example, this match phrase option. In this case, so this is how I declare the body. I use match phrase. And what it does basically in this case, because I don't, by default, it basically just matches exactly the phrase that I enter. In this case, I'm asking when Barack Obama was inaugurated, so it's going to be searching exactly that. Although you can actually define your own analyzer here and decide how exact this phrase is going to be. Well, just to show you, well, basically it didn't really find anything because there is no such article, not such exact phrase anywhere. So if I just ask Barack Obama, it will find the Barack Obama article. But it's, yeah, basically there are other options like multi-field search that I've also tried, and see how I declare here a list of fields. So it would be searching in title and in text, and for some articles that's good, like for the Barack Obama article, because really what I want is to find that particular article. Although it still, unfortunately, doesn't really quite work. It still returns the Barack Obama article the second. So we'll work on it some more, and there is a feature that's called dynamic boosting. There's actually a static boosting as well, but basically here you boost a particular field right during the time of querying. So here I choose that the title field will be boosted by 3, which means that the score calculated from what was found in the title will be multiplied by 3, and the match is not boosted. And yeah, so this time Barack Obama article is at the top. So that was helpful. There's also, just want to show you real quick, you can do a quick multi-field search with boosting when you just have this list and a caret 3 or whatever your boosting coefficient is. That's just kind of neat. I wanted to show you, but the result is the same. So if you see that there is some weird results here, like coronavirus for some reason, and I think that the probable reason for that is because the default tokenizer in Elasticsearch is this n-gram tokenizer that splits this query that you give it into n-grams of size 1 and 2, which is like this. So it looks like coronavirus might have many similarities in that sense with Barack Obama. Yeah, so, well, as you can see, still not really all quite perfect. So there's something we can do next is to reindex the documents. And instead of keeping the entire body of text in one field, we instead split it into sections and keep it in a dictionary of dictionaries with different section names. Another reason to do that is because our chatbot actually kind of chokes on a large text, and it is better to give it smaller but more relevant text so that it can come up with a better answer than trying to search in a large article. And sometimes it comes up with an answer from bibliography, for example, which is not great. But to build a nested document, unfortunately, we cannot really use the default mapping that Elasticsearch provides. So we need to use we need to declare explicitly the data types and the structure. What I do here is I tell it that the text field is going to be nested, and the properties of this field inside the nested dictionary here, they're like this. There is an integer field, which is section number, and 2 text fields. Just to confirm, I'm printing this out, and this is the structure. So in the last part of it, once you have this nested data, the way that you query it is actually different too. Because the fields are no longer the same. So basically I have to write out this query body like this and tell it that I want to search in text section content, and I give it my question. And then this what's happening here in the second query here, I tell it that I want to look in summary section. And then when I look in summary section, here the question that I'm asking is, what are the symptoms of coronavirus? And it tells me this is the article where the answer is. And that was pretty good. So yeah, that was it. And I just want to wrap up real quick. Can you see my PowerPoint this time?
All good.
Okay. Yeah, so the next things for us to do is to probably build more complex and customized queries so that we can actually get as better search results as we can. Probably add some customized analyzers, because right now the Elasticsearch, the problem with it doesn't really handle very well this multi-word expressions like Barack Obama, or there was another question that I was asking who was Stan Lee, and it had really big trouble with it because there's unfortunately many Stans and Lees out there. Yeah, so there's some work to do, but I hope that this kind of tutorial will be helpful to somebody who is just starting out with Elasticsearch. Yeah, so, and real quick, one more thing is that I wanted to say big thank yous to everybody from Tangible AI, Hobson for his support and mentorship, and all the awesome guys who I met there. And if you can help, and you want to help, I include a GitHub link, and Hobson is the guy to ask about.
Any questions?
I have one question. This is Robert. Do you have a good resource for learning more about Elasticsearch?
Well, actually, Elasticsearch has really, really good documentation, although certain things, like I mentioned, that you cannot really create a nested document unless you declare the structure, that was kind of hard to find, and I Googled a lot, and I ended up trying this. So these little things, I guess, are sometimes hard. And actually, I'm going to probably upload this Jupyter notebook on both Hobson's NLP bot repository and on my own repository. So if you want to check it out, or at some point you just need some starter code, then it will be there.
Thanks.
But otherwise, their documentation is really, really good.
I have a question. Let's say, I wonder, you said that you were playing with Elasticsearch only for a month and a half, but like, do you feel that like you've only like scratched its capabilities and there is more there, or you feel that other improvements will already need to be your own?
No, I feel like there's actually a lot of flexibility that it gives you. I really want to look into custom analyzers, and well, there's also, like I said, there is an out-of-the-box machine learning platform for someone who wants to monitor, traffic on their website, or maybe what's going on with their computer resources or server resources. That's a great, well, so yeah, basically even for the search, I think even for the search, I haven't really scratched the surface, but there is a lot more out there. And I think it's a great platform to check out.
Thanks.
Thank you.
Well, thank you for listening.